Welcome to a new test and teardown video. This time it's another Hewlett Packard. The 1710B oscilloscope. This one is a 2-channel 200 megahertz oscilloscope, and I think it was released in 1976. It's very heavy. This one is 13.4 kilos. So yeah, it's definitely in the heavy end. The fun thing is, if you Google a little bit around on the 1710, you also find a 1710A. And the A version looks very, very different. It's also only a 150 megahertz. It's two completely different oscilloscopes just by this little A or B. So if we look at the picture right here, this is of course my B version, and I will put in a picture of the A version so you can see the big difference. I'm quite happy to see we got a modern power supply connector, and the voltage selector here is a little bit funny. I don't know if you can see the little white dots. Probably get a little, yeah, now we go with the white dots. So I think it is configured for 220 because this one is up and this one is down. But I want it to be configured for 240, so I want to pull down this one right there. So this one is selected and this one is selected, and there you have it, the 240. So far, so good. I don't know if you can, yeah, you can probably see the dirt here a little bit. And this is also some of the dirt. This is how the whole unit looked when I got it. The front was just splattered with all sorts of nasty goo, a thick layer of something like that. And it took me a few hours just to make it a little bit presentable for the video here. There's not a lot of stuff in it here. I mean, why is it so heavy? So that will be the 2-time base. So here we go. Let me see if I can get a little bit of light here. So it's a dual time base, obviously. So this is one, this is the other one. Got the little clickety down here. Some adjustments for all the different timings, and all that looks pretty fine. And the switches and all this is of course in sockets down there, the green one, so you can pull it out. And I think the design is from 1976. I will go and double check with the date codes on some of the ICs. We got some HP ICs right here, and yeah, I think that is pretty cool. A BNC connector inside like that for a service. Pretty cool. And that is a part of the power supply and deflection system. It's very good to note. Don't use metal screwdrivers, and you're going to stick this in here and you're going to get a funny surprise, definitely. I haven't yet found the delay line. I hope there's a delay line. I see some deflection stuff here, and also we got some deflection stuff down there, so this is probably where it is. So that goes here, and this goes to, yeah, okay, so that, here we go. What is that? I'll see if I can have it here in a nice balance point. This is of course the vertical deflection amplifier, a special chip made by HP, and obviously this is a very fast analog scope. So you have two sets of deflection plates, or you access the deflection plates in each end of the system. So see, here we go. This is each end of the deflection system going to the amplifiers for correct drive, impedance, speed, and all that fancy things. And also what I find here is that little coax cable here, and you see a little reel through that hole of coax cable wounded up down there. And this is of course the delay line to the vertical amplifier system. The bottom part of the unit is just so beautifully designed. Let's start with the power supply. So we got all the low voltage power supplies. We got the transistors here on the back, very good thermal design. And we got some rectifier bridges down there. They are a little bit close to that capacitor here, and it seems like they aren't really connected. I mean, they can't really cool down to chassis, so the heat will spread in this area to the nearest capacitors. But I guess all this is not super high power, really. You can see those tiny little transistors reveal that it's not super high power. We got a little bit of dirty stuff here, so it looks like something dripped out of the capacitor and then is down there. But this is actually my fingers. This is the layer of, see, when I touch it, I get this nasty, sticky. This is just all over the place, also inside. How annoying. So this is the delay line. Look at that massive reel. I think this is the first time I see a delay line this crazy. I mean, it's long. And also this is a balanced delay line, obviously, and depending on the different design in those delay lines, this could explain why this one is so long. So if it's not a coiled design, but a straight design of the two balanced wires that goes through this, then it could explain why they made it so long. Obviously, I would expect, the coiled design will require a much shorter length, but it's also very difficult to make it super good. Actually, there is a little bit of distortion in that design. So if you want something that is really good and you don't mind the size and the weight and the cost, then make it with straight technology and then a super long coil. The end of one end goes of course to the vertical deflection amplifier, and the other end, as you can see here, goes to the left. And it comes up right there. See, we got this balanced feed point, and this goes, of course, to their special balanced high-speed amplifier circuit that is right there. And there you have the two input channels with some amplifiers and transistors and good stuff, and then it goes like that, and then we're done. All the other stuff around here, that's just support stuff. This is not where all the super high speed goes. They really wanted to keep the signal path as short as possible, and then we're done. Otherwise you can't do a 200 megahertz scope like that, right? So that will be the horizontal deflection amplifier. This one has absolutely not the same requirement for speed and fantastic things. So this is just a regular circuit board like that. It's quite packed. From this side we see all the different all the different boards here. This is the mains on-off switch, and that switch is located at the very front. So mains is going in a shielded cable in a completely shielded switch. So this is also intensity, I think, isn't it? scale illumination. That is what it is. So that's some low voltage DC stuff. Yeah, if this would have been Tektronix, there would be a long stick, and then the on-off switch would have been located down here. That's just how they did it. They didn't want to have all these wires going all over the place. And here we see some more support, some slow speed support stuff for the input, and that will be the attenuator. And this is made like an RF attenuator. Look at that, in a shielded multi-section switch for all that. It's just how you do stuff when you want it to go really, really fast. When I went through the instrument before I even opened it, I noticed the channel A variable here was really loose. Look at that, the whole potentiometer here is completely loose. And I think it's just this nut that is causing all this problem. I did expect to find a little hole in this piece of aluminium that will kind of stick to this or lock to this, but that seems not to be the case. It's just a tighten the nut that will solve that. There's another thing that bothers me a little bit about this design. I don't know if you can see this little slider down here. It can move between AC, DC, and ground and all that, but then see, there's also this 50 ohm setting, and the idea is you pull it out or bend it out, and then you turn it all the way down to 50 ohms. And let's look at the other one that is not broken yet. I mean, the amount of force, I'm grabbing it all the way down here, because if I do it on the top, it's gonna bend. But if you take it all the way down here and then you push it down there, and then I really don't like this. Yeah, and here we go. That is the 50 ohm setting. Yeah, this is the, see? And this is why this one broke. Of course, this is channel A, and this is the one everybody's using all the time. Why don't people just use channel B all the time? That is something funny, but that is just how it always is. So this one breaks, and I don't know how to repair it or anything, but you can actually move it, see, just by using your nails like that. So it can be moved, but it's just really, really difficult. I feel lucky. So let's try and power this up. So of course I have it in power off first, and then I try and give it mains input, and of course I see no usage. So I'll try and dial up here. 67, 68, 70 watts. And now it goes down to 65. And then let's see if we have the scale illuminate. Yes, look at that. So there's a background beam. So there's a flood gun or something like that. What? That is some interesting way to do that. And what else have we got here? I think I see a little line there. But that is more, oh, intensity is here. And then focus is completely out of the, see, here's my time base. I get a little bit of response. This looks like, oh, see? It looks a little bit like I am doing something wrong here. What have we got? I want to play a little bit with this. What is the, it's not responding to any position here on channel A or channel B. That is alarming. So we have definitely a mega problem with input, but we also have a we've got a lot of problems. See, focus is also completely out of the way, and it's not responding so much to intensity. So I believe we got also a power supply issue. Well, well, well. See, that is the trigger. So auto trig, normal trig, and then it's still making, and then if I move the trigger level, see? then it's not working like that, and then auto level works. So at least that. Hold off the trigger. Well, let's go measure some stuff. So I've been fighting with this annoying scope for the last few hours. I was about to give up, and I've been poking around with the focus and brightness and all the different voltages, and I also realized my high voltage board is a new model and not the original model, so I had to find another schematic. Yeah, I had to cut the board here in one end because they made it so you need to take the entire scope apart to get this damn board out. And if you just cut the edge here a little bit, then you can easily get it out and still keep the entire scope intact. So service trick, you don't need this corner. There are no traces in that corner. So what is that? So we have a white wire here, and that is the voltage for the focus potentiometer. Now I need to go and figure out where is this supposed to be located on this board. So I don't know if it's me or if it was already like that when I tried to get this board out. I did a lot of wiggling around, but this white wire is the end of the focus potentiometer right here. And of course the white wire goes into point number 9. That is that one. The red wire here is something else. So, but look at the wire. This is a stiff wire. So that means if you bend this a little bit, it will break. That is a quality issue I really don't like. I already invested way too many hours on this unit. But now the white focus wire is connected, and let's see if I am any more lucky. Nah, it was not that. And it is just the way it is with those CRTs. I've been riding with all those experts that knows all about these old CRTs, and they say they get gassy and they get weak, they get out of focus, they get, like this. So I mean, all the things I've been through is just, fixed now, and it should definitely be fixed. But that is not the case. I actually found another bug, but it's not worth fixing because of this. See, if you see my sweep is going on like that, right? See, if I move channel A, see I have A, and if I hit bandwidth limit, okay, bandwidth limit, now position works on channel A. And the fun thing is, this is also how it's documented, I mean, in the schematics. So that means you lose the ability to move the position if you're using more than 20 megahertz, as it says here. And I just cannot believe it. If this is really, really true, why the heck did I even bother trying to repair this thing? Because that is just the most useless. I mean, I must have read the schematic wrong, but it's definitely looking like what it's doing. It's disabling. This is doing exactly what I read in the schematic, so I totally don't get it. So I think that will be my last and final rant about this one. It was not funny at all. I am really, really sad that I didn't make it work, because I think it has like a sexy look, and I really like the 200 megahertz and all that kind of stuff. It could be pretty cool, but also the shape of the screen is nice. But well, not today. That is what it is. So thank you very much for watching. And if you know what to do, please tell me. And I will, of course, keep this unit for the next 10 years and just play with it now and then when I feel bored. But let's hear from all the experts, okay? You please tell me what to do. And I will try it and comment and what else happens here. Bye bye.